Good morning, everybody. Can you hear me? Great. My name is Mark Tarry. I'm the CFO of a company called AMP. And I guess I'm here because we believe that there, at the moment, is a great opportunity to invest in biomass CHP. And that opportunity is really being driven by the RHI in large part, but also in the medium to long term by the prospect of rising wholesale gas prices. So AMP, we would describe ourselves as an integrated distributed energy business, and the group has various trading subsidiaries, which include Forest Fuels, Billington Bioenergy, and HW Energy, in which we own a controlling stake. And the group really operates across the energy supply chain. We supply energy in the form of wood fuel, so we are a supplier of wood pellet and wood chip. We supply about 170,000 tons a year of wood pellet into the RHI market. We supply about 200,000 cubes plus of wood chip into the market as well. But we're also a supplier of heat, so we can contract with customers to supply them heat on the meter. And by doing so, we take the efficiency risk of the biomass boiler installation or the CHP installation. And we are responsible for the operation and maintenance of the system. And that substantially de-risks the heat contract for the customer. And we probably have upwards of 500 boilers that we currently manage in this kind of way. And then we're also a supplier of ESCOs. So the difference between the ESCO and the heat supply contract is that we will also fully fund the installation. And as the asset owner, we would take the RHI, and that's what generates the return on capital. But a customer will still contract to buy heat on the meter, and we take care of all of the operating and efficiency risk. And then increasingly, the focus is moving towards a flexibility approach, and we have just commissioned our first 21 megawatt peaking plant, which is running off gas, and that's very much to take advantage of the increasing price volatility we're seeing in wholesale power markets driven by renewables and intermittency. So yeah, we're very much across the supply chain, but I guess we would say our core competence is in biomass. So I guess the context, why do we think this is important, and why do we think it's important now? I think we'd all agree that we've done quite a good job on decarbonising power, decarbonising electricity, mainly through solar and renewables and wind. But on renewable heat, we haven't done quite as well, and we're behind targets. So we have a 12% target by 2020 to have renewable heat, and as of 2016, renewable heat only accounted for about 6%. And we believe that the greatest decarbonisation potential in heat really is in the manufacturing and process heat sectors, so in manufacturing and process heat applications. If you look at the RHI deployment data today, you'll see that the majority of installations have been biomass boilers, and the majority of those are 90-degree hot water type installations between 199 kilowatts and a megawatt, providing hot water for space heating and hot water. Not really in the process heat market. And we think that if we're really going to make a dent on this target, we need to get better at getting biomass into industry and manufacturing, where there is a real need for high quality heat. And by that, I mean steam that's of a certain pressure and of a certain quality that can be used for process applications. But the benchmark for us is gas. So there's no point talking about biomass if we don't believe that we can compete with gas. Many of our larger customers are on gas, historically have been on gas, and if they're going to make the switch away from gas to decarbonise, we need to be able to compete with the price of gas. And we think that CHP enables you to do that. And the reason why it enables you to do that is because it enables you to revenue stack. So you get the benefits of on-site power generation and the avoided grid charges that come with that. But also you get to use all of the heat and hopefully use that heat usefully. So it's the avoided grid charges from producing power on site in combination with the RHI as a subsidy. And and I guess the ability to really outperform comes from being clever and smart with fuel choices. And as the biomass market has evolved and matured, there's an increasing range of options around fuel and fuel blends, so that fuel can be more cost effective. And what we're sort of finding with a lot of our customers is that they have very challenging payback periods. These systems are typically expensive. The capex is typically multiples of a standard gas boiler or even gas CHP system. And a lot of large customers have very challenging payback periods. 3 to 5 year payback periods are not untypical. And those kinds of IRRs and yields are, they're typically inconsistent with energy investment. So energy investments typically have taken place on much lower yields. And so there's a challenge to get customers to actually invest in these systems at the moment. But at the same time, what we're seeing is, and particularly with the ending of ROCs and the challenges of competing within the CFD for solid fuel technologies, infrastructure investors that are focused on inflation-linked yields, government-backed yields, are looking for a home, looking for an opportunity to invest. And we think that the RHI remains a very attractive market for infrastructure investors to invest in. And with that, we hope comes a lower cost of capital and an opportunity at the moment to deploy these assets into sites. So why CHP? I'm sure many of you will be familiar with the benefits of CHP, but I guess just by way of a recap, even before considering the carbon benefits of switching fuel from gas or oil to biomass, the fact is that the traditional method of power generation, a large transmission-connected power station, in aggregate isn't that particularly efficient because the majority of the energy in the form of heat goes up the chimney. And what CHP enables you to do is to capture that heat and use it usefully on site. So I guess the starting point, if you were to look at the right-hand side of the slide, that shows a biomass CHP system. And we've used numbers from a specific system. It's a thermal hot oil boiler in combination with an ORC, and we'll come on to talk about that in a bit. But using that system, if you put 100 units of energy in, you'll get approximately 15 units of electricity out, and you'll get about 77 units of heat out, and hopefully in the form of high-quality steam. So you're running at about a 15% electrical efficiency and about a 77% thermal efficiency. Now, if you were to achieve that by buying your power off the grid and by installing a state-of-the-art gas boiler running at, say, 92% efficiency, to get your 15 units of power, assuming that the grid on average is running at a 32% average efficiency factor, again, that's a big assumption, but it's probably not far off the mark. In order to generate 15 units of energy, you're having to put in 47 units of energy. So 47 units of energy becomes 15 units of power. And then if you have your boiler in situ on site, in order to get your 77 units of heat, you need to put 84 units of energy into your boiler. So if you sum up your 47 units and your 84 units, your total energy input from a mains connected system with just a simple gas boiler and importing power from the grid requires 131 units of energy versus 100 units of energy into your CHP system. So irrespective of your choice of fuel, just using a CHP system delivers huge energy savings for the system in aggregate. And ultimately, that is why the government is very keen to support CHP. So why biomass? Well, the obvious answer, I guess, is that biomass is considered carbon neutral. Despite the fact that when you combust biomass, it gives off carbon dioxide. Clearly, the point here is that as trees grow, they sequester carbon dioxide. So carbon dioxide that's released through combustion is sequestered as trees grow again. What is absolutely fundamental to the integrity of the scheme is that biomass is sourced from sustainable sources, that biomass is grown and harvested in a sustainable way. The other key point is, as I mentioned right from the outset, is that it continues to be incentivized by the RHI, and the RHI is a very attractive subsidy at the moment. It's a 20-year inflation-linked subsidy, and that is, and in a world when there are fewer and fewer subsidies available to investors, that's particularly attractive. The buzzword at the moment and the buzz topic is obviously around batteries at the moment. Biomass and your biomass fuel store is by another name a battery. It is a store of baseload energy. It enables a user to have energy either in the form of heat or power when they need it. And that's incredibly important for an industrial user. And what we're finding, as I said at the outset, is that as the industry matures, fuel blending is becoming increasingly more sophisticated. So we can use much more of the tree in our fuel blends. So rather than just taking the whole log and chipping that, we can take sawmill co-products, so the bits of the log that aren't used to make sawmill timber, and combine that with forest residues, so the tops of the trees and the branches, to make a more cost-effective fuel that can help us compete with gas. And the key thing about forestry is that it's a long-term, mature, established market. Forests take a long time to grow. The industry has been around for a long time. It's we have a good industry in the UK, and what that means is that we are able to contract on long-term contracts, and that's very different to a lot of fossil fuel, gas, and oil contracts where contracting terms are much shorter. And what that means is that you can create much greater price certainty on your energy procurement decisions. And what we also know is that in 2019, there's going to be a substantial increase in CCL rates, particularly on gas. So I think on gas, rates are going to go up by 67% from 2018 to 2019, and that will have a real bite on big users of gas. So taking that in combination, combining the benefits of CHP with the carbon neutrality of biomass is, we believe, incredibly compelling, and will enable industrial users to drive real big decarbonisation benefits, when, to be frank, their options are pretty limited if their only choice is to use gas and oil to create that high quality steam that they need for their processes. So in terms of price forecast, it's always a dangerous thing to put a price forecast on the screen because, as we all know, the world changes pretty quickly. But what we've tried to do here is to take a reference point. So the reference point is shown in the red circles. So in the top graph, you've got gas prices. So on the historical look back, you can see that gas prices historically have moved up and down quite a bit. Probably on aggregate, they've trended upwards. And we're now in a situation where if you take Bayes' very large customer gas survey, on average, those kinds of customers are paying about, today in 2017, are paying about 1.58p per kilowatt hour of gas. Now you put that through a existing gas boiler that's maybe only 85% efficient, and the price of heat on the meter is about 1.86p. So if that's your starting point, you take 1.86p and you extrapolate it by two things. The bottom line is extrapolating it by the Bank of England's target rate of inflation, so 2%. And the top line is extrapolating it by the Committee of Climate Change, their price forecast for gas over the next 20 or so years. And what you can see is there's a marked difference. So gas prices are set, if you believe the Committee on Climate Change, they're set to substantially outstrip the growth in inflation over the next couple of decades. And so what we believe we can do is, and because of the unique nature of biomass, is we believe that there is an opportunity to contract in the long term on on more of an inflation basis. And what that means is greater energy security. So whether the forecast is correct or not, whether the curve is steeper or shallower, the point is if you can contract on a long-term basis and you can link that to inflation, you immediately have greater price certainty on your procurement and your energy costs. And we think that in itself is incredibly powerful. Under this situation, clearly your savings is basically the area underneath the green and the black lines. And again, the analysis can be replicated for electricity prices. The Bayes survey for electricity prices in 2017 sees prices about 10.3p, 10.4p in 2017, and all we've done there is extrapolate the prices by the rate of growth anticipated by the Committee of Climate Change and inflation. And again, you can see a divergence between the two. So we think that there is a real opportunity now, given the potential upward trends in wholesale gas prices and electricity, to lock in greater security on your heating costs by using biomass. We've looked. We're not a technology company. We invest in a variety of different technologies. But we think that there is a particular combination at the moment that is very exciting, and that combination involves the pairing of a biomass boiler that produces thermal hot oil, so oil at very, very hot temperatures, up to 400 degrees C. And these boilers are quite robust, and the advantages of that is that they have much greater flexibility on fuel choice. The boiler produces this very hot thermal oil, and that thermal hot oil goes into an ORC that is capable of producing steam. An ORC, or an organic Rankine cycle turbine, is different to a steam turbine because it uses an organic working fluid rather than water and steam. And that organic fluid, that working fluid, has a higher molecular mass, which means the turbine doesn't have to spin as quickly. It takes a lot of the pressure off the turbine, which means greater availability. The manufacturers will warrant availability numbers of upwards of 95%, and we have seen turbines in the field that have an availability of 99%. And that makes it incredibly compelling for an on-site, in-situ application. It also means that maintenance costs are very low as well, or relatively low. And we think that's really advantageous for industrial users of heat. And this particular turbine that's been developed is capable of producing steam at a variety of different pressures and a variety of different outputs. But for us, we think that the greatest opportunity is in between the 5 and the 10 megawatt range of heat. So we did a comparison of various different technologies for making steam. And again, the focus we believe has to be on steam, because it's steam that is that high quality heat that can be used in processes. And if the benchmark is a new steam boiler, what we're saying here is that if you are faced with two choices, you either go down the route of a biomass CHP system, or you continue to invest in steam. Your opportunity is to invest in a new steam boiler that, a state-of-the-art boiler might be 92% efficient. So for every unit of gas you burn, you're losing about 8% in the form of heat that can't be recovered. So if that's the benchmark, what are the options for CHP? If you go to the far right-hand side, that is kind of the profile for a steam turbine operating at this kind of scale. So we're talking about sub 3 megawatts of electrical output, and we're talking about a 10 bar pressure steam coming out of the turbine. You can see that in aggregate, you've got about 9% losses compared to the 8% losses under the gas boiler. So in aggregate, as an overall system efficiency, it's pretty competitive. But the electrical output is relatively low. And the reason being is because the steam pressure at this scale is low, and therefore the electrical efficiencies are relatively low. In contrast, if you look at a reciprocating engine, you can see that the electrical efficiency is 44%. It's much higher. But the challenge with a reciprocating engine is that you can only raise steam off the exhaust. So the heat that you could otherwise recover from the water jackets can't be used for that high-grade quality heat. So if you discount that heat, your losses are much higher. They're 38%. In contrast, the technology pairing I was describing, the thermal hot oil boiler and the ORC, delivers the same aggregate efficiency. So we're only talking about 8% losses, but it's going to deliver 15% electrical efficiency to be used on site. And it's that production of power which obviously has the CHP revenue stacking advantages, those avoided grid charges, which enable CHP to hopefully compete with the price of gas. So if many of you are familiar with ORCs, the traditional constraint with an ORC has been that the quality of the heat, the temperature of the heat, and the steam pressure coming off the back of it has been low and therefore not been as useful to manufacturing users as we would want. The real innovation here has been that by changing the thermal fluid, we can now put a much hotter thermal fluid into an organic Rankine cycle and get temperatures of between 165 degrees and 213 degrees out of the back of an ORC, coupled with all of the benefits, the operational benefits, availability benefits of that turbine, and a range of efficiencies between 12% and 15%, depending upon the pressure at which the steam is required off the back of the ORC. So again, we think that this combination at the moment is particularly unique and particularly interesting. So I mentioned at the beginning that there are the funding, on-balance sheet funding is potentially a challenge because these systems cost quite a lot of money. Corporates, their core focus is on their day-to-day business, and CapEx is often committed to that with some pretty challenging payback periods. The alternative is to try and fund these assets off balance sheet via an ESCO. And we believe that there are long-term investors out there that want to have access to this market. And so the way that an ESCO works is that an asset company will typically own the asset. So in the middle of the box, you've got Asset Co. So Asset Co will buy the CHP system, and it will contract with the end user of heat. So the end user of heat will contract with Asset Co to buy heat and power at a price per kilowatt hour. And typically, there will be a requirement for a minimum offtake. So the end customer will need to commit to a minimum amount of heat and a minimum amount of power. And those contractual minimums obviously underpin the cash flows to the asset-owning company. The obligation of Asset Co then is to deliver heat in the right form, in the right quality, the right pressure to the end user, to the customer, and to provide all of the other services that go with running that asset. So that includes the procurement of fuel, it includes the management of the system, from O&M to the provision of on-site labour if required, and any development services that go with making this project a reality. And Asset Co typically generates a return on its capital by receiving the RHI. So as the owner of the asset, Ofgem pay the RHI to Asset Co. And it's that generates that government-backed inflation-linked yield that our investors are very, very keen on. But crucial to the success of Asset Co, we believe, is not only the way in which you procure fuel. So you want the smart projects will be those projects that can procure the cheapest fuel, but in the most consistent form as possible. But it will also be those projects that can secure the right kind of funding. And we believe that key to getting these projects away is long-term funding, because the ESCO has to deliver immediate cash flow savings, advantages to the customer. And the way that we go about doing that is by having long-term funding, which means that the amortization, the repayment of debt takes place over a longer period of time. And that enables us to pass on greater savings to customers right from the get-go, right from year one. So key to this entire proposition is about an integrated approach. It's about security of supply on the fuel. It's about procuring fuel smartly, and it's about procuring the right kind of funding. But if you can marry all of those things together, we believe that this an ESCO proposition is very compelling for sophisticated users of heat that that have other uses for their capital and have some pretty challenging payback periods and hurdle rates to try and meet. So again, the advantages of ESCO ownership. An ESCO funding arrangement, an off-balance sheet funding arrangement, or even an on-balance sheet funding arrangement is only going to work if actually there is a discount to heat and power. The only reason to do this is that by doing it, you're going to save money on your heat and your power. But preferably, also you can lock these savings in. So the terms of the contract, if you can contract on a long term and if you can link those savings to inflation in some kind of way, we believe that's incredibly powerful. So the prerequisite for any kind of ESCO or on-balance sheet funding arrangement must be that the price of heat and the price of power must be at a discount or be competitive to the price of gas and mains power, and ideally inflation-linked to create that stability and to remove that exposure to volatile fossil fuel prices. The other sort of advantages to the off-balance sheet arrangement is around efficiency risk. You'll be familiar, anyone who runs a system will know that the efficiency of the system fluctuates through time, and that is a function of the way it's managed, the type of fuel that's used, the maintenance regime, and so on. And the advantage of the ESCO arrangement, the off-balance sheet arrangement, is that somebody else takes care of that problem. So they are absolutely incentivized to ensure that the right fuel is used, that the right maintenance program is followed. And a lot of that day-to-day hassle is removed from the on-site user, again, enabling them to really focus on their core business. So no efficiency risk, no operation and maintenance risk. That's taken care for the customer. And no fuel supply risk. All of the risk is borne by the ESCO operator. And crucially, no capex. And if we can attract institutional money to this market with a longer payback period, with a lower return on capital requirement than an industrial commercial customer might have, we believe that's a real advantage to both the end user and to the end investor. Now, just I guess in the spirit of being an FD, there are accounting rules that are coming down the pipe with respect to leases from sort of 2019. It will be increasingly challenging to have these kinds of arrangements off balance sheet. It's not to say it's impossible, but under new IFRS rules, it's likely that these arrangements may constitute on balance sheet funding arrangements. So I mentioned at the beginning that we think that this is a great opportunity, but it is absolutely a time-limited opportunity. If the economics are underpinned by RHI, then obviously the obvious risk here is the availability of RHI. And what you can see here is the applications for RHI. So the green bar is preliminary applications for CHP. The yellow bar is forecast expenditure based on full applications. The red bar is forecast expenditure based on applications, but applications that have not been paid yet. And the blue bar, which is rather alarming, is accredited applications that have been paid. So obviously Ofgem are struggling with paying folk at the moment. But the point is that Ofgem take into account both preliminary applications, full applications, and folk that have been accredited, paid or not paid, as the case may be, and they compare that to a threshold, which is basically that line, the purple line. And the point at which those bars break the line is the point at which digressions will start to trigger. And digressions basically mean that the RHI rates start to come down. And it stands to reason that as the RHI rates start to come down, the economic attractiveness of these projects start to diminish. So I guess the key message for us is we believe this is a fantastic opportunity, but it is a time-limited opportunity. And the real the best projects will be available to those folk that can move quickly. So I guess why biomass CHP in conclusion? We believe that decarbonisation will remain a key component of the CSR and the board agenda. And we also believe that at the moment there are still incentives in place. There are carrots in place for decarbonising, but with time those incentives will go away, and that the carrot will be replaced with legislation and with a stick. And so the opportunity now is to decarbonise, but to lock in long-term incentives rather than have to go through the pain of penalties and legislation that may or may not be coming down the pipe in the next few years. And we believe that the CHP is the right product for industrial users of heat. We believe that, particularly with this combination of a thermal oil boiler and an ORC, we can deliver that real high quality heat and that on-site power to avoid grid charges and really improve the economics of a biomass project. And we also believe that there is this really unique funding opportunity at the moment, with investors looking for long-term inflation-backed yields that aren't immediately available in other energy markets. If you look at the power market at the moment, increasingly investments are being made on merchant risk. The RHI is a pure 20-year government-backed cash flow, which we believe is very attractive at the moment. But at the end of the day, it doesn't necessarily have to be CHP. CHP is really ideal for baseload users. Biomass boilers, biomass heat can still work for applications that don't run baseload. And there are lots of examples where that still holds true today. So that's it from me.